Good morning, everyone. Very good morning. Shall we begin the session? Today's topic is aggregate functions. Yeah, these are the functions that is used in SQL. This is not the programming. This is not the PLSQL that is programming SQL, but these are the functions that is also known as aggregate functions. So this function takes a collection that is a set or the multiple as an input and returns a single value. There are 5 functions over here. One is a AVG, one is a min, minimum, max, maximum, sum for the total, count for the count function, or counting the number of the cells, counting the number of the fields, whatever the count that we required. Okay, so just wait for 5 minutes more for others. So let's begin with the session with the aggregate functions. So, first of all, the theory of this. What is the meaning of aggregate function? That are the function that takes a collection that may be a set or the multi-set of values as inputs, that takes more than one value as an input and returns a single value. So aggregate functions are the function that takes a collection of the values as the input and returns a single value. SQL also offers 5 inbuilt aggregate functions. One is the AVG, that is the average. One is a minimum, that is a min. One is a maximum, that is a max. One is a total, sum. One is a count, that is a count function. So the input to the sum and the AVG must be a collection of the numbers, but the other operators can operate on the collection of the non-numeric data types. So this is a string. Because if I want to find the maximum, minimum, that is also find out with the strings as well. So one is a AVG functions, one is a min function, one is a max function, one is a sum function, one is a count function. Next is the basic aggregation. So consider the query, find the average salary of the instructors in the computer department or computer science department. So we write this query as follows. So select AVG salary from instructor where department name equals to computer science. So what is the meaning of AVG salary? So it is used to find out the average of the salary from the instructor table where the department name equals to computer science. So the result of this query is a relation with the single attributes containing a single tuple with the numerical value corresponding to the average salary of the instructors in the computer science department. In the same way, there is a database system that may gives an arbitrary name to the result relation or relation attribute that is generated by the aggregation. However, we can give a meaningful name to the attributes by using the as clause as follows. So there is the select AVG salary as average salary from instructor where department name equals to computer science. So we are giving the alias name, that is the AVG salary. So that is average salary as a AVG underscore salary from the instructor where the department name equals to computer science. And in the instructor relation with the salaries in the computer science department, that is 75,000, 65,000, 92,000. So that is the average balance is 232,000 divided by 3. That means what is the, how it is calculated, addition of these 3 salaries, that is divided by 3 because there are total 3 salaries. Yeah, in this the as is used for giving the alias name. What is the alias name? That is a AVG underscore salary. So we have to find the average salary, that is a function AVG and AVG salary. Then we are giving the alias name that is used as AVG salary. Now the output is coming out with the field. What is the name of the field? That is the AVG underscore salary. And retaining the duplicates is important in computing an average also. Suppose the computer science department has a 4th instructor, for example, whose salary happens to be the 75,000. So if duplicates were eliminated, so we will obtain the wrong answer, that is yes, because it is divided by 4. And the correct answer is 76,750. So there are multiple cases in which or where we must eliminate the duplicates before computing an aggregate function, because there is no need of the duplicates, because if we don't remove the or if we don't eliminate the duplicate, so we use the keyword distinct. We have studied about the distinct. Have you remembered about the distinct? Yes. So we have to use the count function as well as a distinct ID. So we are taking out only the distinct ID because ID is a primary key. So function is a select count distinct ID from teachers where semester equals to string and year equal to 2010. And because of the keyword distinct preceding IDs, even if an instructor teaches more than one course, he is counting only once in the result. Because we are defining out, we are getting out the aggregate function, that is a count, to count the number of tuples in a relation. And the notation for this function in SQL is count asterisk. Therefore, to find the number of tuples in the course relation, we write select count asterisk from the course. This is the ID, the name, then department name, then salary. So 76766 is the correct, then biology 72,000. There are 4 fields over here. One is ID, one is a name, one is a department name, one is a salary. So the tuples of the instructor relation that is grouped by the department name attribute. Now computer science are grouped together, biologies are grouped together, finance is grouped together, history is also grouped together, physics is also grouped together. And SQL does not allow the use of the distinct with the count asterisk. It is legal to use the distinct with the max and the min, even though the result does not change. But we can use the keyword all in place of the distinct to specify the duplicate retention. If I want that the duplicate data will come, so we use all keyword. But since this is a default, there is no need to do so, because by default it is taken out the duplicate values. Now next is how to use the aggregation with the grouping. So we are using the group by function, we are using the where, having, and we are using the group by. So there are multiple scenarios, circumstances where we would like to apply the aggregate function not only to the specific tuples, but with the group of the set of the tuples. In that case, we are using the group by clause. So tuples with the same value, what is the meaning of tuple? That is the rows with the same values and all the attributes in the group by clause are placed in a one group. As an example, find the average salary in each department. So we are taking out the department wise. Yeah, for example, the physics has a there are two parts of the physics. One is a gold, one is a history. There are two employees. So the average salary is calculating by the addition of the two salary that is divided by the two. On the other hand, however, the computer science has a three fields or three employees. This is the addition of the three salaries divided by three. So there are circumstances where we would like to apply the aggregate function not only to a single set of tuples but also to a group of set of the tuples. So we specify this wish in SQL using the group by clause. The attribute or the attributes given in the group by clause are used to form the groups. And the tuples with the same values on all the attributes in the group by are placed in a one group. That is the same example, physics, computer science. Now, yes, right, same. That the biology does not have any attribute, that does not have any duplicate data. So that is the same. This is 72,000. So this is a select department name. Select is a keyword, as you know. AVG is also a keyword, but department name may be changed. This is the field name. In the same way, salary is a field name, and as is a keyword because this is used to define the alias. In the same way, AVG underscore salary, that is also that is also not a keyword. We can change them. We can also use total, credit, whatever that you want. From instructor, what is table name is the instructor, and from is a keyword. Then group by the department name. So it is grouped by department name. So this shows the tuples in the instructor relation that is grouped by the department name attribute, which is the first step in computing the result of the query result. And the specified aggregate function is computed for each group, and the result of the query is expressed. Now this is the output of this. There's a department name biology that is the same 72,000. But if I'm talking about the computer science, there are three fields, three salaries, 75, 65, 92. Now if I add these three one, this is 23 to 2,23,000. It is divided by the 3 and gives the output as a 77,333. In the same way, electrical engineering, let's see, there is nothing, so it's 80,000. Finance has a 2 fields, 9 and the 8. This is 170,000, that is divided by the 2, not 3, because there are only 2 salaries. In the same way, history has a 2, divided by the 2, addition of 2. Then music does not have, physics does have a 2 fields. This is 91,000. There is a biology, computer science, electrical engineering, finance, history, music, and the physics. The result relation for the query, find the average salary in each department. And in this case, the group by clause has been omitted, so the entire relation is treated as a single group. And as another example of the aggregation on the group of the tuples, so we use the query, find the number of the instructors in each department who teach a course in spring 2010 semester. In the same way, when you talk about the information about which instructors teach which course section in which semester, that is available in the teachers relation. And this is joined from the instructor relation to get the department of each instructor. So we write the query, select department name, count distinct ID as an instructor count. From instructors, it is natural joins with the teachers where the semester equals to spring and the year equal to 2010. And this is grouped by the department name. And when an SQL query uses a grouping, so it is important to ensure that the only attribute that appears in the select has been aggregated that are present in the group by clause. For example, when you talk about the query that is enormous, since ID does not appear in the group by clause, it appears in the select clause without being aggregated. This is an enormous query. Select department name, ID, average salary from instructor where it is grouping by the or grouped by the department name. So each instructor in a particular group that is defined by the department name can have a different IDs, and since only one tuple is output for each group, and there is no unique way of the choosing which ID value to be the output. So as a result, such cases are disallowed by the SQL. Now next one is a having clause. This is used to state a condition or give a condition that applies to the group rather than to the tuples. For example, we might be interested in having or only those departments where the average salary of the instructors is more than the 42,000. So let's take an example. This is select department name, average salary as average salary from instructor, where it is grouped by the department name having. Now this is grouped by the department name, but it is using the having, that is having average salary is greater than 42,000. So we are taking out the average salary. The condition is that average salary is more than 42,000. Not equals to 42,000, but more than 42,000. That means 42,001, 42,500, anything, but not 42,000 because we are not giving out the equals to sign. So as was the case for the select clause, any attribute that is present in the having clause without being aggregated must appear in the group by clause. Otherwise, the query is treated as anonymous. And the meaning of a query containing aggregation, grouping, group by, or having clauses is defined by the sequence of the operations. Now, these are the various examples of the query that includes the group by, that includes the having clause that is defined in the sequence or by the following sequence of the operations. As was the case for queries without aggregation, the from clause is first evaluated to get a relation. There's the department name, average salary, physics 91,000, in the same way electric engineering 80,000, and so on till history 61,000. And if where clause is present, then the predicate of grouping in the where clause is applied on the result relation of the from clause. And whatever the tuple that satisfying the where predicate are then placed into the group by clause if it is present. And if the group by clause is absent, then the entire set of the tuples satisfying the where predicate is treated as being one group. In the case of having clause, if it is present, it is applied to each group, and the groups that does not satisfy the having clause predicates are removed. Then the select clause that using the remaining groups to generate the tuples of the result of the query, that applying the aggregate functions to get a single result tuple for each group. So to illustrate the use of both having clause and the where clause in the same query, so we'll consider the query for each course section offered in 2009. Find the average total credit of all the students enrolled in the section, if it has or if the section had at least 2 students. Now next is the aggregation with the null and the boolean values. How to deal with the null values and the boolean value, that is zeros and the ones. Null values, when they exist, complicates the processing of the aggregate operators. For example, assume that some tuples in the instructor relation can have a null value for salary. So this is considered a query for the salary amount. Just to select some salary from instructor. And the values to be summed in the preceding query includes null values, since some tuples have a null value for the salary. Rather than say that the overall sum is itself null, the standard or SQL standard says that the sum operator should ignore null values in its input. And in general, aggregate functions treats a null according to the following rule. Whatever the rule, that the aggregate functions except the count star ignore the null values of the in the input collection. Okay. Now let's talk about the nested subqueries. That means query within a query. So SQL also provides a mechanism for the nesting subquery, that is a select from where expression is that is nested out within another query. And the common use of the subquery is to perform the test for the set memberships, to make the comparisons, to determine the set cardinality. Yes, that is performed by using the where clause. Having every keyword, every clause is used within the nested query, because this is also a query, but this is query within another query. That's why it is known as a nested subqueries. And SQL also allows the testing tuples for membership in a relation and the in-connective test for the set memberships, where the set is a collection of the values produced by a select clause, and the not in-connective test for the absence of the set membership. Now this is one of the examples to find out all the courses taught in the fall, in both the fall 2009 and the spring 2010 semesters. So earlier we wrote such a query by intersecting two states, the set of the courses taught in fall 2009 and the set of the courses that is available or that is taught in spring 2010. So we use the ID that is a select course ID from section where semester equals to spring and year equal to 2010, with the need to find out those courses that were taught in fall 2009 and that appears in the set of the courses obtained in the subquery. So we do so by nesting the subquery in the where clause of an outer query. So this is select course ID from section where semester equals to spring and year equal to 2010. This is select distinct course ID from section where semester equals to fall, year equal to 2009, and course ID in select course ID. Now this is the next query that is known as the subquery or the nested subquery. So this is select course ID from section where semester equals to spring and year equal to 2010. This is the select distinct course ID and so on, where semester equals to full and year equal to 2009. This example shows that that it's possible to write the same query several ways in SQL, and this flexibility is beneficial since it allows a user to think about the query in a way that seems more natural. And we shall see that there is a substantial amount of the redundancy in the SQL query that is used in the not in the construct in a way that is similar to the in constructs. We are using the in construct or the not in construct at the same way. So this is select distinct course ID from section where semester equals to 4 and year equal to 2009, and course ID not in select course ID from section where semester equals to spring and year equal to 2010. Then the in and the not in operators can also be used as an enumerated sets. And the following query selects the name of the instructors whose names are neither Mozart nor Einstein. Select the distinct name from instructor where name not in Mozart and the Einstein. And in this case, in the preceding examples, we tested membership in a one attribute relation, and that is also possible to test for the membership in an arbitrary relation in SQL. For example, we can write the query, find the total number of the distinct students who have taken the course sections stored by the instructor with the ID 110011. So this is select count distinct ID from takes where the course ID, section ID, semester year in select course ID, section ID, semester year from teaches where the teachers.id. Now the ID is taken out from the teachers, that is 10101. Next is the set comparison. So select distinct t.name from instructor as t and instructor as s, where t.salary is greater than s.salary and s.department name equals to biology. Now this is a subquery for this that we have already done. This is not even course. Now subqueries in the from clause. We are also using the subqueries by the use of the from clause. The select department name average salary from select department name average salary as avg underscore salary from instructor where group that is grouped by the department name where the average underscore salary is greater than 42,000. So this is taken out with the two fields. One is the department name, one is the avg salary, and from which there's a inner query that is select department name avg salary as a avg underscore salary from instructor that is grouped by the department underscore name where average salary is greater than 42,000. And the subquery generates a relation consisting of the names of all the departments and their corresponding average instructor salaries. Note that we do not use having clause since the subquery in the from clause computes the average salary, and the predicate that was in the having clause earlier is now in the where clause or the outer query. So we can give the subquery result relation a name and the rename the attributes using the as clause. Then next is the with clause scalar subqueries. Now next is the modifications of the database, how we can modify in the database. One is a deletion, we can delete the rows, we can delete the database, we can drop the database, we can drop the tuples. Then insertion, we can insert the rows inside the tuples into the relation. This is the syntax: insert into table name, values, then what are the various values that is given to the various fields. Then updates, we can use the insert, we can use the delete, we can also use the update. So for example, if I want to increase the salary by the 0.5% because there is an increment each and every year, the salary will be increased by using the set or update table name, then set salary, that is the salary multiplied by 1.05. Where the update may contains constructs legally in the where clause, where that is insert, delete, nested subquery within an update statement that may reference the relationship that is being updated. This is the update instructor set salary equals to salary multiplied by 1.05. The salary is greater than or less than select average salary